The launch of the James Webb Space Telescope, JWST, in December 2021 was one of the most highly anticipated events in the history of modern astronomy. As a successor to the Hubble Space Telescope, JWST was built to revolutionize our understanding of the universe. With its immense capabilities, the telescope was expected to peer deeper into space and time than any telescope before it, unraveling the mysteries of the cosmos in ways that were once thought impossible. The words of Thomas Kochen, the former NASA science director, encapsulated the optimism surrounding the project. James Webb marks the beginning of a new era in astronomy. Webb will expand and test our cosmology and our understanding of planets and the origin of life. For a moment, it seemed that the cosmic mysteries would finally unfold before us, bringing clarity to the enigmas that have baffled scientists for centuries. However, instead of providing clear answers, the JWST has, in some ways, thrown us into deeper confusion. What began with immense hope has turned into a series of unexpected challenges, leading to what some are calling a debacle. Scientists, once certain about the models and assumptions that have governed our understanding of the universe, have found themselves grappling with data that does not fit neatly into the established framework. Far from dispelling the mysteries of the cosmos, the discoveries made by the James Webb Space Telescope have raised new questions that challenge the very foundations of modern science. Could it be that our understanding of the universe is flawed? Could we be on the verge of a scientific revolution, or are we simply being misled by data that we don't fully understand? The idea that we might be making mistakes in our fundamental understanding of the cosmos seems unfathomable to many. After all, the laws of physics, developed by giants like Sir Isaac Newton, have provided us with an extremely successful framework for understanding the universe. These laws, which govern the motion of objects and the forces that act on them, were once thought to be universal and unchanging. Newton's discovery of gravity, in particular, allowed scientists to describe the behavior of celestial bodies with remarkable accuracy. Over the centuries, these principles formed the basis of astrophysics, the science of understanding the physical properties and interactions that govern the universe. Scientists were able to observe distant stars, galaxies, and planets, and by applying the same laws that govern life on Earth, they could make predictions about the behavior of objects in space. Yet as our observational technology advanced, particularly with the launch of the Hubble Space Telescope in 1990, we began to notice anomalies. The universe, we had thought, was governed by predictable rules. We had assumed that distant galaxies and cosmic phenomena would behave in much the same way as objects we observe on Earth. However, as our ability to observe deeper into space grew, so too did the realization that some of our assumptions were no longer holding true. It became apparent that there were things about the universe we didn't understand, things that classical physics could not explain. The real crisis began when astronomers started measuring the age and expansion rate of the universe using different methods. The measurements were simply not agreeing. Local observations of galaxies, made from within our own cosmic neighborhood, suggested one rate of expansion, while measurements based on the cosmic microwave background, CMB, the afterglow of the Big Bang, indicated a different rate. This disagreement is known as the Hubble tension, and it remains one of the most significant puzzles in modern cosmology. The tension between these two sets of measurements raised a troubling question: could it be that our current understanding of the universe's expansion was fundamentally flawed? Then, in the summer of 2022, the James Webb Space Telescope made its first groundbreaking discoveries. The telescope's ability to detect incredibly faint light signals from distant galaxies opened a new window into the early universe. For the first time, we were able to see light that had traveled through space for more than 13 billion years, providing us with a glimpse of galaxies that formed shortly after the Big Bang. These galaxies, which appeared to be highly developed and mature, shocked the scientific community. According to current models of cosmology, galaxies should take billions of years to form and develop. Yet, the galaxies observed by JWST appeared fully formed just a few 100 million years after the Big Bang. How could this be? How could galaxies already be so mature in the infancy of the universe? These discoveries raised new doubts about the age of the universe itself. If galaxies could form so quickly after the Big Bang, then the assumption that the universe is 13.8 billion years old might be incorrect. Some researchers began to question whether the entire cosmological model, based on the idea of an expanding universe and the slow evolution of matter, was fundamentally flawed. Was the Big Bang theory wrong? Had we misunderstood the history of the universe? This revelation shook the scientific community to its core. For decades, the Big Bang theory had been the dominant explanation for the origin and evolution of the universe. It suggested that the universe began as a singularity, a point of infinite density and temperature, approximately 13.8 billion years ago. Since then, the universe has been expanding and cooling, allowing galaxies, stars, and planets to form over billions of years. But the new discoveries made by JWST suggested that the universe might have behaved very differently than we thought. Some scientists even began to entertain the idea that the universe could be far older than we had imagined, or that it had gone through multiple cycles of creation and destruction, a theory known as the cyclic universe. As the implications of these discoveries began to sink in, it became clear that our current understanding of the cosmos might be incomplete. We were at a crossroads. Could we continue to apply the physics that works on Earth to the entire universe, or were we missing something fundamental? Perhaps, as the ancient scholar Hermes Trismegistus once said, as in small things, so in great things. In other words, the forces that govern the cosmos might also operate on Earth, but maybe we have yet to discover them. The discoveries made by JWST are forcing us to question everything we thought we knew about the universe. The technology behind the James Webb Space Telescope is nothing short of revolutionary. The telescope's 18 honeycomb-shaped mirrors allow it to capture faint light from distant galaxies that has traveled through space for over 13 billion years. This unprecedented ability to see the most distant reaches of the universe, combined with a special exposure method that reveals the faintest traces of light, has opened up a new frontier in our understanding of the cosmos. Yet, as exciting as these discoveries are, they have also led to a crisis in cosmology. The galaxies that Webb has observed appear to be far more developed than they should be, given the age of the universe. Scientists have struggled to reconcile these findings with the conventional understanding of cosmic evolution. Some even suggest that these galaxies are impossible or that the images from JWST are not real. But the truth, it seems, is that these galaxies are real, and the science that we've relied upon for centuries may no longer be sufficient to explain what we're seeing. The fact that these discoveries challenge our understanding of the universe is not in itself a failure of science. Science is always evolving, and sometimes the most profound discoveries come when long-held beliefs are overturned. It took centuries for the scientific community to accept the heliocentric model of the solar system, and even longer for the Church to concede that the Earth was not the center of the universe. Today, we may find ourselves in a similar situation, where the scientific establishment is reluctant to let go of outdated theories, even in the face of overwhelming evidence. But this resistance to new ideas is not unique to cosmology. Throughout history, revolutionary scientific discoveries have often been met with skepticism and hostility. The story of Galileo Galilei, who was persecuted for advocating the heliocentric model, is a stark reminder that scientific progress often requires challenging the status quo. Now, the field of cosmology is experiencing a similar upheaval. The new discoveries made by JWST have forced scientists to confront the possibility that our understanding of the universe is flawed. Some researchers, like Rohan Naidu and St. Finlin, the astronomers responsible for discovering the Glass C11 galaxy and Massey's galaxy, are part of a new generation of scientists who are more open to revisiting the fundamentals of cosmology. They look at the data from JWST with an open mind and are willing to entertain the idea that our models may need to be updated or even replaced. This willingness to embrace new ideas is crucial for scientific progress. While some of the more traditional researchers may resist these changes, the younger generation of scientists is excited by the possibilities that the new data presents. One of the most pressing issues in modern cosmology is the Hubble tension, the discrepancy between local measurements of the universe's expansion and those based on the cosmic microwave background. For decades, the expansion rate of the universe was thought to be well understood, but recent observations have thrown this certainty into question. The JWST has the potential to resolve this tension by providing more accurate measurements of the distances to galaxies and their redshifts. If the Webb telescope can solve the Hubble tension, it could pave the way for a new era in cosmology, one that might require us to rethink the very nature of the universe itself. The journey to unravel the mysteries of the cosmos is far from over. The discoveries made by the JWST are just the beginning, and many more exciting revelations are yet to come. The telescope is already providing us with new insights into exoplanets, distant galaxies, and even our own solar system. Each new discovery adds another piece to the puzzle, bringing us closer to understanding the universe's most profound secrets. But it is important to remember that this journey is not just about finding answers. It is also about questioning the assumptions that have guided our thinking for centuries. The discoveries made by JWST are a reminder that science is an ever-evolving process, and that the pursuit of knowledge is as much about asking the right questions as it is about finding the right answers. As we continue to explore the universe, we may come to realize that many of the theories and models that we once thought were set in stone are actually incomplete or even incorrect. But rather than being discouraged by these uncertainties, we should embrace them as opportunities for growth and discovery. The challenges posed by the James Webb Space Telescope's findings are not roadblocks, they are invitations to rethink everything we thought we knew about the cosmos. This is a time of unprecedented scientific